Please.
So hello, thanks for joining this talk. We're both from Starmind, as already said. His name is not Steven, it's Steen.
Sorry?
He's Belgium. It's a very common name in Belgium, even though we can't really pronounce it correctly here. So we're going to talk about the Starmind technology, which tries to bring the human to the center again by using AI. So what is Starmind? We're a startup based in Küsnacht, so canton of Zurich. It's not the city of Zurich, but almost. We are 35 employees. We have offices in Frankfurt as well as in New York. And even though I said we're a startup, we're actually pretty established already, so we have lots of big clients and a pretty big user base, where you see our product. Maybe you even have used it already. We provide white labeled version of our product. For example, at Swisscom it's called Ask the Brain. So people from Swisscom are here, they would know it. So what do we do? Everyone who works or has worked in a big company knows that actually most of the knowledge of a company is not documented on the SharePoints and databases and data lakes and what's not, but it's in people's heads. So all the knowledge that was gathered there. So that's where we focus on. This is, we say, the 80% of the knowledge within the company and not the documented, explicit indexed knowledge. That is where Watsons crawl and get their correlations. That's it. That is where we focus on. So how do we do that? How do we get to know what is in people's head? Where people are experts in? How do we do that? In the following, I don't know how many minutes, 25 minutes, we try to give you a little insight, also in more technical depth, on how we achieve that. So what we first need to do in order to do that, to get to this 80% of the knowledge, we need to understand the language used in a company. So we build what we call a dynamic know-how network. Important to see here is that it's dynamic, so it's something that actually grows by usage of our platform. So it's not something static in the beginning and it stays like that all the time. Once we have that, we check what kind of usage patterns we can track. So we track every interaction with our platform and check the usage patterns in order to extract expertise profiles and know-how profiles. So, and once we have that, we can actually build our, the end user product on top, which is connecting the right people. Okay? So, how do we understand the language? How do we do that? This is how we build our knowledge network, know-how network, by identifying terms, extracting terms, and building them in a huge networks and connect them with edges, weighted edges, which are then learned by the system. So the cues here, what you see, those are actually questions posed into the system. And we extract topics from there and build relations between the topics. So once we have that, what we do is we track what kind of interactions the user has with our system. So there's over 30 different interactions that we track, which are then fed into the model. Maybe something important to see here is also we track how users interact with each other. So I'm sorry this is all pretty theoretical for the moment, but you will see what I mean later on when I show you the demo, hopefully. So this is just to get you in a state of mind to understand how it's all built. So I was talking about this knowledge graph. This is how it might look then. What you see here is a stain. And stain, what we have in the end is we are actually able to connect certain topics to users, so we know who's an expert on what, and we also weight these connections. So Stan is an expert in Scala. He also loves hiking and has a PhD in math. So this will be shown by our system. This will come up by pure interaction of Stan with our system. So he never entered like, I know machine learning and I'm an expert on machine learning. That's something we actually learned by interaction of Stan with the platform. So, and this all then leads to what we can then use that for is, if someone has a question, we can say to which topics this question belong, and from these topics we can infer the right experts. I say experts, so it doesn't have to be an expert, but mostly you have more than one. So that's one functionality that's possible thanks to this knowledge of who knows what. So instead of just talking theoretically about all of that, we're going to show you the application and how this all looks. So just imagine you work in a big company like Accenture, for example, which has 400,000 employees. So you don't know anyone, everybody. This is simply impossible, right? So we have the system where you can go, and it's important to notice that this is our default front end, but what our customers do, sometimes they don't even use that. They just fully integrate all the technology, the core technology, in their intranet or in their mobile apps or wherever, and you don't even see that there's Starmind under the hood. So this is our default front end, and here we have stream. You can search for stuff. And you have questions that have been asked. You can recommend experts. You can answer, you can comment, all the typical question and answering things that you do. So now imagine you're in a big company and you have a question. And what you would do then is you would go here and start typing the question.
As Ivan is typing, you will see that even while he's typing, we're already doing some processing. So you can see there's similar questions coming up. So we look for existing content, existing questions and solutions that already exist in this Starmind network that might be relevant for the question that Ivan is now asking. Maybe even the same question was already asked, maybe in some different wording, but there might already be some answer available that solves the question without Ivan actually having to publish a completely new question. How do we find these similar questions? We use a vector embedding for that. So basically all question solutions are mapped to vectors in a higher dimensional vector space. And vectors that lie close together would correspond to texts that are similar in content and meaning. So we also can convert the text that Ivan has written to a vector, and then we look for question solutions that are close to this vector of Ivan's text, and those have similar content and might be relevant. The exact algorithm that we use for this vector embedding is called reflective random indexing. It's maybe slightly lesser known vector embedding algorithm. It's a fairly simple one. It just uses a bag of words model, so it doesn't do any complicated grammatical analysis, but we found it to work quite well for this use case. The other thing that you can see is there's tags there, so these are kind of keywords that describe the topic that this question is about. We have an individual list or database of tags for each Starmind network. As you can imagine, for a pharmaceutical company, the topics that are relevant for them are quite different from topics that would be relevant in a telecommunications company, for example. So this database of tags is unique for each Starmind installation. And what we do to automatically find text that would be suitable for this new question is, on the one hand, we look through this database of text and try to match it with the text that Ivan has written. So this is a bit more involved than just comparing the words. We also do some stemming to make sure we can deal with different forms of the same word, plural, singular, or other declensions. We measure the edit distance between the words that Ivan has written and the text that are in the database, so we can deal with small typos. We can even deal with synonyms or related terms to a certain extent. The most interesting thing, though, is that we don't even need the tag to exist in the database. We can also automatically create new tags when necessary. As you can imagine, it often happens that some question comes up on a completely new topic and there's no relevant text in the database yet. What we can still do then is we can still automatically add some tags to this question. We do some natural language processing for that, in particular part of speech tagging. Part of speech tagging means you identify for each word, this is an article, this is an adjective, this is a noun, this is a verb, and so on. And there's some different factors that come into play, but the most important indicator to know that something might be suitable as a tag is it being a noun. So noun in this sentence would be AI, artificial intelligence. That indeed is a good keyword to use to describe the topic of this question. We've got tags, we've seen similar questions, but haven't found any useful information. As you can see, you can also manually change the tags if necessary. Now we'll submit the new question, and as soon as it's submitted, Starmind will look for experts for this question. So it will look through all of the users in the database and try to match this question with the profiles that we have for each user. So in the background, it's a bit simplified, but you can think of it as a graph with edges connecting these topics, these tags, with all of the users. And the edges have weights, so the higher the weight, the stronger the connection of the user with this topic, and if the weight is 0, there's basically no connection between the user and the topic. Now, it's a bit more complicated than just adding the weights of the different tags that are involved, because you can think, for example, of a scenario where you have a question that's about IT and about machine learning. Now, IT is a much more general topic, much wider topic, whereas machine learning is much narrower, much more specialized. And probably what you want is an expert on machine learning, and rather than an expert on IT in general, who might not necessarily have in-depth knowledge of machine learning, whereas your machine learning expert will automatically have some general knowledge of IT. So that's, for example, one thing that you need to take into account there. As you can see, this is also a different part of our application where we have some statistics about different tags and connections that we have in our network. And here you can also search for experts without actually having to publish a new question. So here you can just enter some tags, and you also get a list of experts, top experts on that combination of topics. The experts that you see here might be a little bit different, though, than the experts that are notified when somebody publishes a question. So when somebody publishes a question, we send out some notifications to those experts. We tell them, hey, your colleague needs some help with this question, and you might be able to provide an answer. However, there you need to take things into account like load balancing. For example, there probably are some topics that are quite popular in the sense that many questions are asked about the same topic, and if you're an expert on that popular topic, and every time a question comes up we keep on sending you notifications, you might get the feeling that Starmind is just spamming you and lose the motivation to contribute knowledge. So there we have a higher threshold before such a high demand expert is sent a notification. Another thing that we take into account is availability of the experts. For example, if you have a question that needs an urgent answer, but it's already evening here in Switzerland, if we might then prefer some expert who is in the United States who will still be in the office, because if you only notify experts in Europe, you probably have to wait at least until the following morning before they will see that there's a new question that's waiting for a response. So these are all things that we take into account, but the most important thing, of course, is the connection between the user and those different topics. So how do we come up with these connections, and how do we learn who knows what? We try to do that as automatically as possible. Of course, at the very start, at least, when we have a new customer, a new Starmind network, we need to start somewhere. So there it depends a little bit what data is available with our client companies. At the very least, they will be able to give us some information about which employee works in which department, so we have a rough categorization to start with. But from there on, we refine those profiles and make them more accurate by looking at what's happening on our application. So we look at what questions are people asking, what answers are people writing, how are these answers then rated by other users. You can recommend some other user as an expert for a certain question. We look at what information you're consuming as well, what you're searching for, and so on. And all of this flows into this model that we have that links the users with the tags and creates these profiles, as you can see here. So there's of course lots more functionality in the software, which we don't have time to go through in all detail, unfortunately. But what would be interesting to mention briefly, if we now maybe go back to the slides, there's a slide about the technology stack that we use to build all of this. So our main programming language is Scala. Scala compiles to JVM bytecode, so it interoperates quite nicely with Java, but it's a bit more functional programming paradigm in it. But the good thing is you can use all Java libraries, Java frameworks, as well as any specific Scala libraries there. So this creates quite a powerful ecosystem where you have lots of functionality, lots of open source libraries available that you can combine and then build on top of to create also the unique secret sauce that makes Starmind intelligence on top of that. But some examples of libraries that are available and that we use. Scala, I think the most famous one is probably Spark for distributed computing mainly. We use Elasticsearch for doing keyword search within existing content, existing questions, solutions. We use Akka HTTP for the API that we have, so the API that both our own front-end uses to communicate with the back-end with the algorithms, as well as other integrations that are built by us or by our clients. OpenNLP is a Java library from Apache where you have functionality like the part of speech tagging that I mentioned to do that we use for the automated tagging. Slick is a database connector for Scala. There's also a Scala NLP library, which in particular has Breeze, which is quite a good linear algebra library, which we use for the vector embeddings that I mentioned earlier, the reflective random indexing that we use for the similar questions, and so on. So it's really quite a nice ecosystem to work with.
So, what is our vision What you just saw, it's already working in many companies and provides help to many, many users around the world. But where we actually want to go, where we aim at, is that we build this AI which knows of everyone within a company what he knows. Not just by pure interaction with our platform, but through every source we can get hold of. So once we have this AI, what we can then do is we can connect people when they can actually benefit from each other. Like the question and answering platform is just one example of that. You can think of many more examples when this is helpful within big companies. And this is an actual need by our clients. So one prototype that we do with a client of ours is actually a combination with IBM Watson. So just think about this use case. You have a chatbot, and here is Bob on the left. And here's a question about traveling expenses, right? So he goes to the chatbot, the company chatbot, and he asks. So Watson's pretty smart, can search all the databases, all the SharePoints, correlates these files to the question of Bob, and comes up with the form about travel expenses, right? But Bob already filled it in, didn't work, some bug on the form, and Watson doesn't know what to do next, so hasn't any more ideas because there's no data which would be able to actually handle that case. So what then happens is Watson asks Starmind, listen, from all this conversation which we have here, who's the expert on helping Bob? Starmind will then recommend Alice, an actual person, to Bob, and Alice will be able to help Bob. So the cool thing about this is, once this conversation goes on, and so we learn from this content again the expertise of Alice, but also expertise of Bob. And also Watson profits from this whole thing because there's more data, right? And if this question comes up again in this form, Watson would be able to answer it from the beginning without needing to connect Alice. So very cool use case. We look forward to that. And what else do we do?
Well, one project that we have going on at the moment to get to this vision is that we want to learn from or integrate different data sources, so we can learn or have much more data to learn from, to learn more quickly, to learn more accurately, and especially include more users, not be dependent on usage of our own application, usage of the question-answer platform to learn about our users and their expertise. So if, for example, Office is used at the company, we could learn from the documents that are being created and who is editing which documents and who is sharing which documents with which other colleagues. SharePoint would offer similar possibilities. What would be interesting as well if there's some maybe some support desk where we can learn from which expert is able to help which support tickets. There's lots of useful information for us in there, obviously. But all of this information from these different sources is very different in form and structure. So in order to learn from that, we need to get this data into some common structure. And the structure that we have, again, a bit simplified, but it roughly looks like this. We still have the text that we saw earlier in the question-answer application. And then we have entities. Entities are basically anything that you can assign text to, so anything that has a particular topic. In Office, this could be a document that's about a particular topic, or a support ticket that's about a particular issue. And in our own question-answer application, this could be a question that has a particular topic. And then we connect users with these entities and implicitly with these tags through actions. Actions could be create a document, edit a document, share a document on Office, and within the question-answer application you have a different set of actions like create the question, answer, rate, share, and so on. So it's different actions, but everything is mapped into the same structure, and once all of the data is into this structure, we apply the learning algorithm that we already have within the question-answer application to create a model, a know-how model, a model that links the users with their expertise from now this much larger data set, so we can unify all the information that's in the different sources. We've been talking a lot about these tags that might sound a bit outdated, old-fashioned, using tags to describe what something is about. And indeed, in some sense, it's a limitation because you make an abstraction, you have a full text in natural language, and if you reduce that to a limited number of tags, you automatically lose some information, some subtleties of what exactly is this about. If you're IBM Watson and you're trying to automatically reply and give an answer to this question, then losing this information would probably be fatal for you. For us, it's slightly less critical, but because we're focusing on those questions, those problems that really still require some human brain power to get to a solution. So we don't aim to automatically answer the question, but we aim to find the right expert for it. But still, we are aware that in certain situations we lose some accuracy probably by reducing this text to a limited number of tags. Now, what's an alternative that we're working on? That's those vector embeddings that I've mentioned before in the context of similar question search. We are looking into using them even more and also assign expertise within these vector embeddings. So you could say like this person is an expert of this area of this higher dimensional vector space, and whenever there's a question that's embedded into this area of the vector space, then this person is probably a good expert for the question. That would allow a much more fine-grained model compared to the tags. But then again, there's some limitations or some challenges as well if you want to do it like that, because there's a lot about transparency or about explaining to the user what's going on. We don't really want to be a black box because this doesn't give the user a lot of confidence. You only need to make one mistake. It doesn't even need to be a mistake, but maybe the user doesn't quite understand why is he selected as an expert for this question or for this topic, and he already loses confidence in the Starmind algorithm, even though in maybe 99% we're actually correct. So that's why we're also working on providing better explanations, providing more information to the user about why has he been selected as an expert for this question. And their texts are much more helpful because you can say, well, we've selected you as an expert because you've already given a good answer to this related topic and so on. Imagine doing that with a vector embedding. You can't really say to the user, well, hey, we identified you as an expert because you are active in this area of this higher dimensional vector space.
So, if people here are actually able to understand these higher dimensional vector spaces, we're continuously hiring data scientists and data analysts, so please approach us if you're interested. We also have what is it? On the job wall, we have we put it there. So approach us or just contact us afterwards. So this was our talk. Thank you very much for listening.